Okay. Hi all. Today we will cover load balancing, application load balancing, and how the application load balancer will route the traffic to different uh, instances. Okay, I mean our application instances, and in AWS load balancer, I mean application load balancer is using an algorithm called round robin. So in lab you will get more idea how the real for example we deploy one application. Okay, so after that we need to route client request to the corresponding machine. So yeah, for example, this is one of my EC2 and this is my another EC2. Okay, in a real scenario we deploy a web application. Okay, coming to on-premise or cloud, we ensure that at least we have two machines, the two identical machines, and the machines contain same configuration files, data, the web content, all thing. Okay. In case if anyone is down, we don't worry about the application down because it will route the traffic to this machine. Got it? Our content is live in all time. That's why we keep at least two machines for real-time web application or some, live application that needs all, I mean, 24 hours running purpose. Yes. And after that, we configured load balancer. In traditional way, we configured load balancer using, I mean, some hardware type load balancer, like uh, some routers or some firewall type load balancer. We configure the I mean hardware firewall, okay, like a device, and we connected all things and configure load balancer inside the firewall or L3 type routers. Okay, so coming to cloud scenario, okay, this is AWS. Consider this is AWS account, and this is our instances. Okay, both are identical, both are having uh, same web servers and same web content. And in front of that resources, I mean that machines, we configure load balancer. This is application load balancer. Okay. In short form, we called ALB. So the load balancer will route the traffic. For example, there is one user's access our content. Okay, this uh, abc.com same content here abc.com. So the request one coming from the client directly hitting our load balancer. Got it? Then the load balancer will route the traffic to corresponding machine. First, this is the first consider this is the first request. Then load balancer will route the traffic to this is VM1 and this is VM2. So same time another request coming from another user or another client. This is client 2. Then first hit our load balancer. Then the load balancer routes the next traffic to the next machine like this. Again, same repeat the same process. Like this process is called round robin. This is not a process, this is an algorithm. round robin. This is a default algorithm that belongs in the AWS load, application load balance. So anyone have any doubts? You follow me, right? Hello?
Yeah,
Yes,
yes,
sir.
yes, yeah. So these missions are in the VPC, right?
Yes. Yeah, without VPC, where we deploy our machine. The prerequisite type, for example, we need to create a virtual machine in AWS. First, we need to configure or create our VPC, subnet, routable, all things. Otherwise, we can choose the default one, but there is VPC. Default
Okay.
or our, yeah. Okay. Now it's clear, right? I mean, my voice.
Yeah, can I ask a quick question?
Yes.
At this time, like, what gonna be the difference between proxy and load balancer?
Default proxy.
Like yesterday, you use like a NGS
Yes,
like
yes.
proxy. So, what gonna be the difference between load balancer and a proxy, like the one you used yesterday?
That is not a continuation of previous class. I mean, this one. Okay. Each one are different topics. Not different because here we can configure Nginx. Okay. For example, here we can configure our Nginx server for our content. I mean, our web content. Same here. Okay. Got it.
Mm-hmm.
Yesterday, I mean, the previous section we discussed about the web servers. Okay. I mean, different types of web server. I mean, common web server, different types. And how we configure reverse proxy using that two type of using the web servers. I mean, Nginx and Apache. That is one of the most common askable questions from the interviewer. So that I include that thing. And as a DevOps engineer, we are the one who set up these types of load balancer, reverse proxy, all things. Not in the virtual machine side, we are working mostly in Kubernetes and Docker. So install all things in the containers, Docker containers or container D, anything like that. Okay. Got it. Hello. Coffee, right?
Yeah, yes.
Okay. So yes, our today topic is load balance. Okay, load balancer, and one lab is here configuring application load balancer ALB. Okay, so the load balancer have some other features like load balancer is continuous monitoring our resources. Okay, for example, these two machines we keep under this load balancer, and continuously the load balancer will monitor each healthy machine. If any machines under unhealthy, then the load balancer will stop the connection between that machine and inform us that one machine is under your load balancer is unhealthy. So many features our load balancer have. Then the main thing is routing our traffic. Okay, I mean, the outside traffic. First, the load balancer distribute the traffic to corresponding machine. Got it? Using the algorithm round
Sir,
robin.
it seems like you're cutting out.
Yeah, your voice is breaking.
Give me a second. Some latency issue, I think. Now it's clear.
Yes, it is clear. Yeah, it's clear.
Okay, fine. Okay. So yeah, that's the thing. I mean, for example, every time the interview asks what is load balancer. Okay, so we can say the load balancer is distributing the incoming traffic to our required virtual machines. Okay, I mean required application servers like that, and the application load balancer using one algorithm called round robin, and the application load balancer or the load balancer will continuous monitoring our machine status and our application code status. All things will monitoring our AWS load balancer. So when coming to creating load balancer, the prerequisite are we need at least 2 machines, and these 2 machines we are added in one group. That group name is called target group in AWS. Okay, so we need to create a group. Name is called target group, and inside the target group we will add our required machines. Okay, for example, consider this is my target group. Okay, target group. So first I create a target group. After I create a load balancer, then I create a target group. Before that, I create these identical machine and install the things and all things. Okay, I mean for installing the web server, then copy the code, all things. Then I configure or load application load balancer. Then I configure target group. Then I add the required machine to the target group. Then attach this target group to the AWS load balancer. Okay. So shall I start the lab, right?
Which target group?
Yeah, target group is a we keep identical machines. Okay, it's a how we can say like it's a logical group. Okay, to keep identical machines.
Okay.
Same group we use for auto scaling. Actually, for the auto scaling, we create a group. I mean, the group name is target group, and we keep our targeted machines inside the target group. Got it? Here our targeted machines are that 2 identical web servers that running the same application. So first I need to configure 2 machines. Okay, I am creating two machines. Here I can directly deploy two machines. Okay, just put your record number of instances. If the configuration is same, then we can follow up this way. Choose the image. I'm here choosing the AWS Linux. Okay, the base machine is fine. My existing key pair I'm choosing, and here we all choose our record VPC. Okay, and the subnet I'm choosing the public subnet for both. Public, I need the public IP, so I'm enabling. And this is for HTTP application, so I'm enabling the port 80 for both. And the source is internet. Launch. App 1. App 1. Copy. PowerShell. You can see my terminal, right?
Yes.
Okay, fine. Just update the package. I mean mission package. Sorry, this VM. Nothing. So I am directly install Apache. Okay, HTTPD. Okay, visible, right? To start system ETL start HTTPD. So the HTTPD Apache system start HTTPD. I think I know to install. It's install. Now installing Apache. Install complete. So I need to enable, I mean to start the HTTPD Apache. I'm using systemctl command. Okay, system. Start HTTPD. Okay, now it's started. You can verify start or not just using status. It's active and running. Okay, you see. So then where we copy our application, in which directory? You guys. I'm asking you.
ETC.
Where?
Okay, slash.
ETC.
Not
Bin.
ETC.
where/www.httpd.
Right. CD var www/html/. This is the directory where our index files belongs. Okay, for HTTP application. Hit enter. Now I am in HTML directory. So ls, there is nothing. So I need to create a index.html file. So I am using nano. two-way we can create, okay? Directly we can use nano editor and give the name and save the thing. Then we will get the index.html. Otherwise, we can create a file using touch command. Touch index.html. Enter. Now there is a file called index.html is created. We can see using ls, but inside the file nothing. So we can see the content inside the file using cat command. These are all Linux command, okay? Index.html. Nothing in that file. That's why here nothing will show, okay? So again, we can use the nano editor index.html, okay? Hit enter. Now I am on the nano editor. So I need to copy some command. I will show some sample thing. So this will be fine. Copy. Paste here. Read and exit. Okay. Now just restart the service. Okay. System CTL restart HTTPD. Now I am good to go to the browser and copy, hit enter. This is the application, okay. Got it. So my first application, deployment of application is done. Then I good to go to the next mission, okay. First we are using Apache 1, Apache 2, 147. Private IP is 2. So this mission is the next one. Copy. Exit. Now I log into the next mission, okay. In real scenario, we will copy the same content, okay. But this is for the demo purpose, and we can see how the load balance will switching, okay. So if I copy the same content, we couldn't see the process, okay. So I will copy some other code, okay, for this machine. That for the purpose of the switching purpose, we can see the switching, load balance switching. Got it? Update. Install. HTTPD. Yes. Now the web server is done. Then going to the directory cd bar www html. Here I am not using touch, okay. I am directly using nano. And the name is index.html. Hit enter. And I need to copy some application. Which one is? You can edit this one. Title. Which one is welcome to this code? Copy. I just edit the same code and copy the enter thing here. Read and exit. And I didn't start the CTL dot HTTPD. That's fine. Okay. Just a copy. paste. Okay, the content are different. Okay, you can see one is welcome guru and one is DevOps. Okay, now I created the first two identical machines. For this scenario, these are not identical because each one have different application. Okay, got it. Therefore, we can see event switching. It will show different application. I mean, these two application we can see when we are using HTTP. Sorry, when you are using load balancer. That's all. Then we are good to easy to console. I mean, this console we can see down the load balance. Okay, you can see load balancer and the target group. Got it. So first we click the load balancer. Then here we can create load balancer. Different types of load balancer. Okay, application load balancer, network load balancer, gateway load balancer, and one more classic load balancer there. And most probably we are using application load balancer because we are mostly work with the application layer. So we are working with the application load balancer. Here the small definition here. Okay, load balance when your flexible features at the application with HTTP and HTTPS traffic. These two traffic we can configure in the application load balancer. And load balancer for advanced routing features application includes microservices Linux. Here in application load balancer, this protocol is using HTTP and HTTPS. And coming to network level, the protocol is UDP and TCP. Okay, these two things happening in network level load balancer, and we configure network load balancer in front of the subnet actually. Okay, don't confuse about network load balancer and application load balancer. Okay, so here I am going with the application load balancer. Create, click create, and first we need to give some name for our application load balancer. So ALB. Demo application load balancer. And the under scheme, there is two options. One is internet facing and one is internal. This is for internet facing, okay, because our applications and our audience is around the globe. Okay, that scenario we need to expose our application. That's why I'm using internet facing. And the internal means it's only for the internal purpose. Okay, using our private IPs. For example, inside our VPC, so many machines there. So we need to routing the traffic between inside our VPC machines. This is not for public, internal. And here we can choose the IP, IPv4 we are using. Then, yeah, coming to network mapping, we need to choose our VPC. So here I am using VPC client for my record machines. For example, I am create two identical machine, and for that machine I'm using the same client. Okay, VPC, same VPC. And for the VPC, at least we need to choose two availability zone. Okay, you can see here, select at least two availability zone for one subnet per zone. Got it? So these are the two availability zones. I'm choosing.
Sir, what is the reason why we have to choose two?
Yeah, because if any availability zone is down, our applications, what happened? It's down, right?
Right.
Yeah. For that scenario, we will make sure. Actually, we are creating load balancer and the entire thing for maximum availability, high availability. So for each scenario, we need to keep the same. For example, first we configure two machines. So that for high availability, right? If any machine down, the traffic will go to the next machine. So our content is available for the users. Same scenario coming to our data center. Okay, if any data center is down, our resources in another data center. So that's why. Yeah. So I'm choosing. When we are choosing these two available zones, these two available zones are in different subnet in my VPC. You see, public subnet and private subnet. When we creating interfacing, make sure our two subnets are routing to internal gateway. Here I am also create another route for my private subnet, and this subnet is now not private, it's public. The name is just private, that's all. Otherwise it will show some error. We need to add that subnet to internal gateway. I mean, create a route to the internal gateway. Got it? Sorry? Your voice is too low.
I'm increasing the volume. Okay. Our question is, when we created these two server AC tools, did we select each of the server into a different subnet?
I think your voice is still not good. I think you are too
So
far.
when we created two servers, we selected same VPC, right? But did we select separate subnet? No, right? They both ECs were on the same subnet, isn't it?
Yes, yes.
But then how come here subnet you are choosing one in public sub, and how you have how it shows different subnets for you here?
Yes, I
Are
mean,
these different? Are these different from the subnet within our VPC?
first I create VPC, okay, then I create two different subnet, then I keep my two machines in public subnet, right? So here I am using, I am just to use the private subnet for balancing the load balancer, okay? In case if any any subnet is down, our resource will there in another subnet, okay? Got it? Got it?
Yes.
So if you don't mind, if you don't mind, can we go back to the server and see what VPC they are?
Same VPC. Same VPC. I am choosing the VPC.
Same VPC, right? Okay.
And I am choosing
And
the public subnet.
These two subnets are within the same VPC?
Yes.
Okay. So for this example, we definitely need to map the ECs to different subnet. That's what you are suggesting?
Yes, I will show you. Just to go to...
Okay. We did not observe when you created the instances.
Make sure all things are under the same VPC. I mean, our machines, because we creating a network, okay, for our resources. Inside the network, we configure all things. Got it? So this is my first machine, Apache 2. This is VPC client, okay, the public subnet. And the Apache 2 is also in my VPC client and public subnet. Got it?
Okay. But what are these subnets?
Which subnet? I didn't get you.
So I see 940A is the subnet where we created them. But what is this C37C, the second one?
That
in the bottom.
Okay, I will show you. Go into VPC. Okay. So here you can see public sub and the private sub. Okay. Both are in same VPC. You see, and the private subnet, we are talking about the private. Okay. C37C.
C37C.
This is here.
Yes.
Got it.
Yeah.
Okay. Then we need to choose at least 2 available zone. Okay. And
These are basically availability zones. These are not machines.
no, these are not machines.
Yeah. Okay.
These are different zones actually. Okay. Not available zones. Okay. Available zone is where our actual physical machines belongs. Okay. It's maybe a server farm or data center or anything like that. Got it. And we need to create a security group for the same. I mean, for our application load balancer. Here I am choosing the same security group for our EC2. I mean, the EC2 security group I am choosing here. So EC2. Or else we can create a security group there and just provide the port number. That's all. Choose any machine and go to the security group. Because in this existing security group, I enable the port. Okay, I mean the 80 that ports. Just this is a security group. That name is security group is Wizard 27. Okay, Wizard 27. First drop down and choose the Wizard 27. Yeah, this one. Okay, fine. And here the listener. Okay, listening and routing. Under listener and listeners and routing. Choose HTTP 80. Okay, this is our listening port, and the protocol is HTTP. Okay, not HTTPS. Port is 80. So here we can see that create a target group, or we need to choose a target group. In drop down, when drop down, there is no thing here. So I need to create a target group. This is a logical group. Okay. I mean a logical group where our identical machines or our targeted machines belongs. That's all. Logically, we grouping that machine. Okay. Here our target group for instance. Okay. That target machines are our instances. So I'm choosing the instances. And so many other functions there, IP, lambda function, application load balancer. And here I am given a name for my target group, short form TG. And here again, we can choose the protocol and the port number and choosing the corresponding VPC. I'm using the same VPC. And I am using, HTTP1, HTTP2. Okay. These are the requests using HTTP1. This is support for request protocol in HTTP 1.1 or HTTP 2. Here we can choose HTTP 1. Okay. And coming to health check, because our target group will do the health check. Okay. Not the target group. Our load balance will health check of our our code. Okay. I mean the code directory. Here I am choosing the default, I mean the root directory, that is single forward slash is the root directory of Linux, choosing the root. Or else we can provide the full var HTML, that thing. Now it's done for the creating target group. Then next, you see, now our target group is done and we need to register our targets. Target means our target machines. Here, Yeah, here our targeted machines is app1 and app1 clone. Okay, so I am choosing app1 and app1 clone and include as pending below. Okay, choose include as pending below. Now it's pending. Okay, it's adding as our target. Then create target group. And you can see this is our target group window. Target group is done, created target group, and port is mentioned, protocol mentioned, target type is instance, all things done. But the load balancer is not associated. Okay, so we need to associate with the load balancer. Then we come back to the load balancer dashboard, window. Then scroll down. Nothing show here, just to reload. Refresh the thing and scroll down. Here we can then list our target group. So click that target group, then scroll down. Everything is fine. So click create load balancer. Okay, successfully created load balancer. Then view load balancer. Okay. Yeah. This is our load balancer and the state is provisioning, under provisioning. It will take some time to active. After completing the provisioning, we will get a ARN, a URL, okay, from the load balancer. So we using that URL for accessing our application. We didn't copy the IP or anything like before. We will get a URL from load balancer. Got it? For the two machines. Anyone have any doubt?
Yeah, please. Can you go back in the target group so we can see what are in?
Yeah, this is the target group.
Okay. You associated the two machine. The EC21 and the EC21 clone, right?
Yes. App1 and app1 clone.
Okay. So here we are in the target group here.
Yeah. These are the machines, our targets.
Okay.
And registered target. We registered before, you see when I click that thing and add the register thing.
And then when creating the load balancer, you have to create a target group.
Yeah.
Oh.
Yeah, you can see now it's active state. Okay, our load balancer, and click the load balancer. Here we can see the detail of load balancer, status is active, host on, and the scheme is interfacing. Everything we can see related things of load balancer. And here we can see the listening rules, listeners, whole thing. And we can see so many options: network mapping, security, monitoring, integration, attributes. These all the things are related to our requirement. Okay. And just to go back to load balancer, you see the DNS name. So this is our DNS name, okay, for accessing our application. Just to copy the application, and yes, I'm pasting here, okay, and hit enter. You see?
Is there any way to create alias because it is so big?
Yes. For example, we need to create DNS records and all so many things related to create a domain name. First, we need to buy a domain name, and we need to add this URL to our A record, insert A record, and routing with the DNS. Okay. After that, we will get the domain name.
Oh, we can't rename it here.
Yeah.
That has to, okay.
We-
Okay.
Yeah, we should have the domain name. First, we need to buy, or yeah. Otherwise, we are using this way or using directly with IP. So, okay. So our load balancer is running. So how to check? This is the first concept. This is a first request. Okay. For example, there is one person access our website. So just refreshing, it will, you see when switching, content switching, you can see, because first thing is go to the first machine, and this time I will get the content from the next machine. So when I refreshing, it will change. Okay. This is called a round robin. Got it? If any machine down, I will get only from the content from that machine. In real world, we are keeping the same code in the same machine. I mean the both machine. So each time we will get the thing. Okay. And if the traffic coming, huge traffic happening, then it will routing to the healthy machine. I mean the load balance will automatically route the thing to the healthy machines. How load balancer will know which machine is healthy or not? Just to go to there. Here we can see in target group. Load balancer target group. You can see in our case healthy. 2 of 2 machines are healthy. If any machine is down or anything, it will unhealthy over here. Okay. If the machine is down or any backend issue, anything like that.
I think temporarily we can stop one instance and see.
Yes, I will show you. I'm just to go to EC2. Okay. So I'm deleting app one clone. Okay. I mean, I'm stopping the machine. Stop. So I'm same time I'm going here and refresh. First day it will route to the next machine. That's why it's a bad gateway. Okay. And going to the load balancer, we can see one machine is entirely to one machine is unhealthy. It will take sometimes unused. You can see one machine is healthy and one machine is unused. If unhealthy, we can see sometimes the machine's error issue or code issue. For example, an application is removed from the directory, it will shows like unhealthy or like that. Now we are not used to that machine. That's why unused machines there. Now it's only route to our single machine. Okay, there is no bad gateway because it's removed from. I mean, in the target group, that this machine is removed. At the same time, when it's routing to the that machine, that's why it shows bad gateway. Can you add monitoring tool like CloudWatch? And yes, Sandro, I am not configuring CloudWatch, but for observability section, I will train you some other most DevOps common tools like Grafana, Prometheus, and Datadog.
I have a question.
Hmm.
Like 2 machines, we have installed 2 machines.
Hmm.
Both have Apache.
Yes.
So we have used only one mission and we have connected load balancer for only one mission, right?
You mean now, right?
Now what we have practiced, we have done a lab, right? For this lab, we have used only one mission or two missions?
Two mission.
Uh-huh.
You see, when I creating target group, I am choosing two machine, our identical machines. These are our identical machine, okay? The
Oh,
two
both
machine
the
have,
app one only, app one, app two, right?
yeah, I just named as app one and app. No, app two is my existing machine. That is not belongs to this lab.
Oh, okay.
That's
Okay.
for an Apache, I think, some other
Mhm.
purpose.
So if we have two separate services on both machines, will it be the same type of process? Like one is having Apache, one is having Nginx.
Yes, we can configure that thing because you are
Okay.
using different web
Uh-huh.
server. That's all.
If a machine is unhealthy, then it will deregister the machine or what it does.
Now it's in when we add that virtual machine to the target group, at that time we need to register that machine to target group. Okay. Now there is a connection. I mean, some logs send it to the target group, so that the machine shown here. Now it's stopped. That's why it's unused. Again, we need to add the machine. We need to start the machine and come here and add that machine again. Got it?
Yeah. So that means we have to restart the mission. Is there any if there are any issues, we need to fix that and then we need to restart that mission.
Yes.
So it doesn't automatically spin up new mission, right?
For that scenario, we need to configure auto scaling. Okay.
Oh, it's
You can
only
see
it does only health check. Right?
yes, here you can
Mhm.
see auto scaling loop. Okay.
Mhm.
So in this purpose, we need to configure auto scaling. So that case, we provide that we have at least two machines. Got it? So if
Yeah.
any machine is down, the access state is two machines. So it will automatically spin up the machine. I mean, the auto scaling group is spin up the thing.
Okay, so the unhealthy missions data will be stored in somewhere, right? When it is deregistering.
Yes.
Okay. Okay.
So if we load balance the HTTPS servers, most of the times we use same web server. For example, if you are going to a Bank of America website, so all instances will have same Bank of America application on the same Apache server. So nobody will install one application on Nginx and one on Apache. So if you are really using HTTPS, HTTP kind of load balancing, all
Yes.
instances will be identical.
Yes. I mean, identical means, I mean the application. Okay. First, I told you all that when we deploying any application in real world or in production, at least we ensure that there is a identical machine there. First to our machine, then we set up the same machine again and deploy the all things in that machine. If any machine is down, our application is still there, okay, running. That's why we need to ensure. For example, in this case, okay, in this case, my machine is down. This machine, consider these machines have the Amazon, okay, Amazon website is running inside the machine. So I am creating only a single machine and deploy the full thing and copy the Amazon application there, and I will put that server into production. So if the machine is down, what will happen? Lots of money, right? And the goodwill of the company, and so many things related to that scenario. That's why we are keeping at least 2 machines.
If we install Nginx, it has by default load balancer, right? So
Yes.
then still we need to configure this application load balancer for that.
That Nginx have some software type load balancer. Okay, we need to configure that load balancer, and it's for a different scenario actually. Got it? For example, yesterday we set up the proxy, right?
Yeah.
So in proxy, the same thing happen. I mean, it's routing the traffic to the required Apache server, right?
Yeah.
That is one kind of load balancing. I mean, the routing the traffic to the Apache. Same thing happening here. This is our load balancer URL. When I refreshing, my traffic is routing to my corresponding machine where my instance, I mean, code is belongs to my instance. Got it?
Yeah, if it is Nginx, so we need not to configure load balancer again. In external load balancer, we need not to do, right?
No. Some there is some application for setting that thing in Nginx, using Nginx.
Yeah, it has that load balancer. So we need not to come and separately attach a load balancer for the Nginx application, right?
Yeah. For this scenario, I mean, when we configure AWS load balancer, okay, so our targeted machines have a web server. If it is Apache, no problem. Nginx, no problem. Tomcat, no problem. And coming to Nginx load balancer, we need to utilize the maximum features of Nginx load balancer. So by default, Nginx is a same as a web server. Okay, got it.
Yeah, okay, thank you.
So some applications we need to configure the Nginx load balance, Nginx as a load balance, software type load balancer. That's the thing actually. And anyone have any other doubt? Clear?
Yeah, after doing the lab, I can say so. No, I can't say.
Sorry?
I think after doing the lab, I can say like,
Okay. This is for application load balancer is nothing. Just to go to the application load balancer. First we need to configure the machines, then go to the application load balancer and give it a name and choose the thing. I mean the VPC, subnet, availability zones, and yeah, these are the things. Then creating target group and add the machines to the target group. Then attach the target group to the load balancer and create load balancer. So the load balancer will provisioning. After that, it's going to active state. Then we will copy the DNS name and paste it in the browser and reload. Got it? And make sure
yes.
both machines in public subnet. Okay. All are clear, right? Anyone? And for NAT and proxy, any doubt? Best and host. This 2x2 check is, right? For the instance level. 2x2 check passed. And my stopped machine is now I started and it's initializing. We discussed, right?
Yes.
Okay. What about others?
Yeah, I know. But I have a question regarding on the Bastion and NAT gateway. So I wanted to know the scenario for Bastion and NAT gateway. Like administrators use these Bastion and NAT gateway, or what is the purpose of using those things?
Purpose of using NAT and Bastion.
Like, NAT and Bastion, but if we may have both Bastion and NAT gateway, right, in the public subnet. So both are used by administrators or normal users?
Normal users, not administrators. For example, how can we say, we have deployed one application, okay, in a private subnet, okay, or we have some confidential machine we keep in private subnet, and some of our employees need to access that machine. Got it? So by default, we are secure that machine. That's why we keep that machine private. So the employees need to work on that machine, okay, that private subnet machine. So that purpose, we will create bash node to access that private machine.
Okay.
That's all up to the requirements. For example, in my company, there is so many employees are using bash nodes for accessing these machines. So we are providing the Bastion. We are in Azure, there is options. They log into the Azure portal and there is an option called Bastion, Azure Bastion. So just to click that Bastion, then they will get their computer. I mean the virtual machine.
Okay, thank you.
Yeah. Any other doubt? Now you see the machine is back state and it's unhealthy. Anyone have any doubt?
This health check is periodically done, or how it is going to like?
I think it changed my IP or something because I stopped the machine. That time it will change. Sometimes IP changes or we need to start the Apache, I mean HTTP code to check that because I didn't enable the Apache. Why we enable the service? If anytime our machine stop or restart, when restarting our service is also running, okay, in background. That's why we enabling the service like using systemctl enable HTTPD. But in my case, I didn't enable. Any doubt? Anyone have any doubt? You can ask. Okay.
So are we going to discuss auto scaling also today?
Not I'm including auto scaling.
Okay.
Because yeah, we need to create another group of machines, and we need to provide some information for auto scaling and that type of scenario there. It will take some time actually. You see, HTTP is inactive. Now it's healthy, you see. Then I just go to here and refresh.
Can you tell me how you stopped the that daemon? How did you stop the daemon? Manually went there and stopped?
In here,
Okay, you connected to the instance and you stopped it.
yes, using systemctl. Systemctl we
Okay.
can manage the service.
Stop
Okay.
HTTP daemon. Okay.
Systemctl. We can provide the command
Stop.
like start. Okay. Start for starting a services, and stop for stopping services, and status for viewing the status of the services. Then restart for restart the services. These are the common things we are using with the systemctl command. After this restart, we can provide the service name. Here HTTP is my service name, or Nginx, Docker, what are services we are deploying, we can choose the services. Now it's again switching. You can see. Right. Okay. Then anyone have any doubt? Anyone? So you can try your own load balancer, right? If I give a task or anything for the weekend.
Yeah, yes.
Yeah.
Okay.
Yeah, we'll do.
Yes.
And I hope everyone done the NAT and Bastion, right?
Yes, sir.
Okay. So these are the basics of networking actually. Okay. So I think some other topics we need to cover like peering and auto scaling. Then we can directly start the DevOps tools for the coming week. Okay. Got it. So I think we can wind up the section, right?
Yes, sir.
Olaf?
Yes.
Okay.
Yes, sir.
Okay. Then okay, bye.
Bye, sir.
Bye.
Have a good day.
Bye all.
Have a good day, sir. Thank you.
Thank you, sir.